There it is. A hole of radius 3 inches is drilled through the center of a sphere, okay, with radius 5 inches. What is the remaining volume? So if you will, well, it doesn't quite, shouldn't make it disappear, but sort of does. What if I go the other way? Now it still disappears. So the idea is this is going to be drilled through there. So we want to look at what happens when we, what am I trying to do? Oh, I'm trying to make an axis. What happens, Lord, look at that. Let's get rid of those. Boop. Get rid of that one. No, not that one. That one. Good. All right. So this is just a circle, right? Basically, if we took a circle and we rotated it about the x-axis, we'd get ourselves a sphere. Okay, and so we're looking at a sphere. There it is. Half circle. Something like that. That's awful, but pretend. Okay, and this right up here, this is 5. Okay, then we're taking this drill bit and we're scooting it through this thing at 3. Okay, so there's the drill bit portion of things. Okay, so all of this stuff in here is gone. All right, so in order to make all of that stuff in there gone, we'll try really hard to erase it, and then stuff back in that I erased in error. So this shape right here, that's what we're going to rotate about this axis to create this little cylinder with a hole in it, sort of thing. Okay, so we've got a circle. We know the equation from a circle. For a circle, x squared plus y squared equals 5 squared. Okay, solve that for the function like we did on one of the problems yesterday. This turns into 25 minus x squared. Okay, and we have a positive negative root. We're just worrying really about the positive portion because we're only above the x-axis. Okay, the equation for this is just y equals 3. That's this line here. Okay, so when we set up our integral, this is my big R, and that's my little r. So, as it turns out, my volume is pi times the integral of square root of 25 minus x squared minus 3 squared. Okay? So we're good to go. We could, we would square this and make it nice, square that, make it nice, integrate. Only problem we haven't taken into account is what are my upper and lower limits. You might automatically be thinking, oh, well, it should be 5. But remember, when we had this thing going all the way down, it came out to here, that was 5. So we're not quite at 5. So we've got to figure out where this equation right here is equal to that equation, just like we've been doing all along. Let's do that up here. So when is the square root of 25 minus x squared equal to 3? Well, that's when 25 minus x squared is equal to 9, squaring both sides. So that's when x squared is equal to 16. So quickly we can get that we're looking at negative and positive 4. Okay? Can you want to work through this one? Let's work through the whole thing just to not leave you hanging on this one, since we might want to find some sort of number out. So the pi coming along for the ride, we said we were going to integrate negative 4 to 4, square root and squaring undo each other. Inverse operations, minus 9. 25 minus 9 is 16. So what we're ultimately integrating from negative 4 to 4 is 16 minus x squared, which is 16x minus x cubed over 3. Okay? Pi times that. We can evaluate that as we would like at 4 and negative 4. Here's a little something that'll save us a little time in the evaluation process. Notice the symmetry, well, the supposed symmetry of this. This is symmetric. Really it is. So it's a symmetric function. So what I could do, instead of integrating from negative 4 to 4, I could just integrate from 4, or from 0 to 4 and double it. it'll be an easier thing to do. So let's just, if you'll bear with me on that for a brief second. Okay, so now I'm going to go 2 pi, it's twice that. I'm going to integrate from 0 to 4, okay, of the same thing, which I just got the integral, so I'm not sure why. Well, I'll just continue with my train of thought. 2 pi 16x minus x cubed over 3, and we're going to evaluate that at 4 and 0. Okay, so it's the same value, it just will save us some time when we're doing the evaluation, because now with the 0 as the lower limit, this whole part drops out, so it just makes it a little easier for us to evaluate. That turns out to be 2 pi 16 times 4 minus 4 cubed over 3. So we're going to have to do some work here. This is 64 minus 64 thirds. Okay. Don't forget the 2 pi. Sorry about the clearing throat. Hope you didn't have your headphones on with that. But 64 turns out to be 192 thirds minus 64 thirds. So I think it's going to leave me with 128 thirds. God, I'm going long on this page. So I'm going to have 2 pi times 128 thirds, which turns out to be 256 thirds times pi. And we generally would leave pi as we've done, just as pi. We don't need to get to that particular number. I suppose if we were ordering the materials, we'd want to, approximate pi, so that, because we're not going to call the supplier and say, hey, we need 256 thirds of a pi of metal to make this thing. But that's a story for another day. All right, so basically, same thing we were doing yesterday. Instead of discs, which were solid, we have washers which have holes in them. So outer radius gives us the hole with the W, and the inner radius gives us the hole without the W. Take the hole and subtract the hole, and we get our volume. I think that's all for today. That should get us there. If you have questions, bring them in, as you've been doing. Hopefully this is still working out for you. We'll see what happens tomorrow. Thanks for listening. Have a good day.